When it comes to NTP versions, version 3 gives us some very robust security. And there is version 4 out there which improves upon it, but version 3 is solid with respect to security. We want to be able to trust the time. Think about it this way. Maybe you're going to go see a movie, and you know you're cutting it close. You want to have really good experience, and you want to get there on time. So you ask someone, hey, what time is it? And then they tell you a time, and you're like, well, are they one of those people that doesn't keep their time accurate? Are they lying to me just to mess with me? And they're rogue, or there's the potential of rogue devices giving you false time, which is going to invalidate certain things in your environment. There are time-sensitive elements. Time-based access control lists. A lot of authentication is time-sensitive, like VPN connectivity and keys for that. EIGRP. So here's how we make sure that we're doing our best to secure NTP. We provide a key. So this is an MD5 hash that is going to be constructed. So you say NTP authentication key 1. That number is significant. It has to match. And then you give it a character string. And then you say NTP authenticate. I do want to authenticate NTP. And you say, here's the key that I'm going to trust. And you would do that also on the client. Basically the same configuration, but when you point to the server, you tack on key of 1 or whatever matches the key IDs that you've configured in your environment. Let's go over to ASW1 and let's do this. So I'm going to say show NTP status. I don't have authentication going on right now, and I'm going to configure NTP. Let's look at our context-sensitive help. I'm going to build the authentication key. Let's give it a number of 800 MD5 with a password of Cisco. And so I'm going to go split screen here. We're going to do that on DSW1 as well. Paste that in to global configuration mode. It moved us to global config. Good. And then I say NTP authenticate. Press enter. Probably don't have to copy and paste that one, but since I've already started, then NTP trusted key 800. And then one final ingredient. I want to tack on the key here. So say key 800, and now I have a properly configured NTP setup going on. Do show NTP associations. So we're not a system peer yet. But if we wait, this will synchronize. So we waited, a little time elapsed, and you can see now that we have re-established our NTP adjacency between ASW1 and DSW1. And let's also do show NTP status, just to look at our output there. Association to an NTP server is great, but you want to make sure that they can prove that they are the server that you believe and not spoofing the time source and giving you false information. With any management protocol, we like to constrain the IP addresses that can manage us, whether we're talking about Telnet, Secure Shell, Simple Network Management Protocol, or, in this case, NTP. You can constrain the IP addresses in this manner. You use a standard access control list. This is really their best purpose in life now, these standard ACLs. You set up an ACL that is going to have the IP addresses or address, in this case it's just one, that is going to be capable of communicating to us. And so you can say here, NTP access group peer 1, and now only those IP addresses that are specified by access list 1 are capable of peering with us. The same could be done for our server. In this case, we're a server, and we don't want to be bombarded by false requests from rogue clients, or maybe from power users who have decided to point to your core and get the time from your core. So what you could do is this. You could say, I'm only going to service clients inside of this subnet. And that subnet might be your management subnet for your gear. So that's a very powerful configuration. So NTP access group serve only. And then the number here ties to the access list that we have configured.